Today we're going to look at box plots, and box plots are a graph that uses the 5-number summary. As you can see over here in the picture, we are comparing high school versus bachelor's, so the highest education level, and we're looking at their earnings in thousands of dollars. So one thing we're actually looking at numeric data, which a box plot is for numeric data, and we're comparing two different categories. So we're comparing high school versus bachelor's. So this is really a graph that allows us to show categorical versus numeric data. All right, so one thing you notice over here is our minimum. We have a whisker that goes from the minimum to the first quartile. Then our box starts, it goes from the first to the third quartile. We have a median is indicated as a line inside the box. And then you have the whisker extend from the third quartile to the maximum. This is just a traditional box plot, but we can also look at modified box plots, which indicate outliers as an asterisk or dot. One thing to note over here is that each part of the box plot includes 25% of our data. So over here from minimum to first quartile, that's 25% between the first quartile and the median. Again, 25% between the median and the third quartile is 25%. And then again, between the third quartile and maximum. When we're comparing two groups like we do over here, the two groups may not be the same sample size, so it's kind of hard to compare like the number within each one of these groups unless we have that information given. But for sure, we know that each quartile includes 25% of the data. We don't know exactly the shape of the distribution. We don't know how many modes, what it looks like. Is it what the shape of the distribution is, just like we were looking at the histogram. But one thing we can tell is that we have a long tail over on the right. You can see that this is much bigger than the tail on the left. And we can also see within the box that this top part is bigger than the bottom part. So when we're comparing the bottom 50% to the top 50%, it definitely seems to be a lot more spread out for the higher earnings over here. Now, when we're comparing two groups like this, high school and bachelor's, we are looking at the overall picture, right? What's the difference between an average, income between someone who completed high school versus someone who completed a bachelor's degree? So that's definitely important over here, and we can see that the median income for someone with a bachelor's is higher than the median income for someone who just completed a high school degree. The other thing we can compare is the range of values over here. We can see that the range overall for bachelor's is much larger than the range for someone who completed a high school degree. Keep in mind that range is a quick and easy thing for us to compare. However, it's not the most descriptive measure of variation or spread. So it's better to use either the standard deviation or the IQR. Now, a box plot very easily displays the IQR of our data. It's simply the width of our box. So we could compare, our IQR, which seems to be just a little bit wider for the people who completed a bachelor's degree versus a high school degree. We can also compare minimums and maximums over here. So for the minimum salary seems to be the same for someone who completed high school versus bachelor, but the maximum is definitely higher for someone who completed a bachelor's degree. The distribution seems a lot more symmetric for high school. As you can see, the different parts are a little closer together, where a bachelor's or where the distribution for someone who completed a bachelor's degree seems definitely more skewed to the right, longer tail on the right. Again, we don't know exactly what's happening inside, but we can definitely see that when we're looking at the upper 50% of the data, it's much more spread out. You see these box plots both vertically and horizontally. So let's look at how we construct a modified box plot. Again, a modified box plot indicates our outliers as a star or an asterisk or a dot. And we would start by finding our 5-number summary. We're going to find the IQR by subtracting Q3 minus Q1. Next, we're going to find our fence values. These are imaginary lines on our plot. They're just lines that determine whether something is an outlier or not. Anything outside those fence values would be considered an outlier. The way we determine our lower fence value, we're going to take Q1, the first quartile, we're going to subtract 1.5 inner quartile ranges from it. And again, anything less than that would be considered an outlier. We're going to find the upper fence value by taking Q3, our third quartile, and adding 1.5 times the inner quartile range to it, and that's going to be our upper fence boundary. Anything larger than the upper fence would be considered an outlier. Anything lower than the lower fence would be considered an outlier. So over here visually you can see on the graph we have the width of the box, which represents your IQR. We're going to add 1.5 boxes over on the right, and we're going to subtract 1.5 boxes on the left. So keep in mind that our minimum is where the whisker starts, Q1 is where the box starts, median is the line inside, Q3 is where the box ends, and our maximum is over on the right. So you can see over here in our illustration that the minimum is not an outlier, but the maximum is. So once you have identified those outliers, you're going to draw those as dots or stars or asterisks, and then you're going to go back to your data set and determine which one is the largest value in your data set that is not an outlier. So you can simply start from largest going down, starting with your maximum. It's an outlier. Look at the next lower value. Determine, is it an outlier or not? See if the next value again is an outlier. Your upper whisker ends at the largest value that is not an outlier. And in the next video, we'll go over an example.